On the morning of July 14, 1944, Lieutenant General Omar Bradley stood in a field somewhere in Normandy, watching a Sherman tank back away from a hedgerow. The tank's commander stood in his turret, hand raised, ready to signal. Behind Bradley, a cluster of officers from the 2nd Armoured Division waited in silence. They had promised him something that would change the war in France. Bradley had learned to be skeptical of such promises. The Sherman's engine roared. The tank lurched forward, gathering speed. 10 miles per hour, directly toward the hedgerow. From the front of the Sherman protruded 4 steel tusks, crude and improvised, welded from scrap metal. They looked absurd. They looked like something a desperate man would build in a field workshop with whatever materials he could find, which was exactly what they were. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The tank hit the hedgerow. The tusks bit into the earthen wall. The Sherman's belly stayed level, protected by the prongs pinning it down. The tank pushed through. Not over, through. A shower of dirt and vegetation erupted as the hedgerow exploded. The Sherman burst into the next field. Intact, level, ready to fight. Bradley watched in silence for a moment. Then he said it would probably revolutionize warfare in Normandy. He was watching the solution to a problem that had been killing his men for 6 weeks. A problem that had turned the liberation of France into a nightmare of close-range ambush and grinding attrition. A problem so severe that it threatened to trap the entire Allied army on the Normandy coast. And the solution had not come from the engineering corps or from the ordnance department or from any of the experts who had spent years planning this invasion. It had come from a 29-year-old sergeant who had listened to a suggestion that made everyone else laugh. The device was called the rhinoceros. Within 11 days, 500 Sherman tanks would be fitted with it. Within 2 weeks, Operation Cobra would launch, and those rhino tanks would rip through German defensive positions that were supposed to be impregnable. The breakthrough would shatter the German line and allow Patton's Third Army to pour through the gap and race across France. But on the morning of July 14th, standing in that field, Bradley was looking at something more profound than a tactical innovation. He was looking at proof that the United States Army's most sophisticated war plans had missed something fundamental about the battlefield they were about to face. He was looking at evidence that the men doing the fighting had seen a problem more clearly than the generals who had planned the invasion. He was looking at a piece of welded scrap metal that represented the gap between what peacetime planning could imagine and what combat required. The hedgerow cutter existed because the Allied invasion plan, for all its sophistication, for all its attention to detail, for all its careful study of French terrain, had fundamentally misunderstood the Norman countryside. The planners had known about the Bocage. They had noted it on their maps. They had even discussed it in their briefings. But they had not understood it. Not really. Not the way men would understand it after watching their tanks belly up on earthen walls while German soldiers with panzerfausts took aim at their exposed undersides. Not the way infantrymen would understand it after watching their friends cut down by machine gun fire from positions they could not see until they were already dying. The story of how the rhinoceros came to exist is not a story of triumph. It is a story of failure recognized and corrected. It is a story of men solving in the field what experts had failed to prevent in the planning. It is a story about what happens when the reality of combat collides with the assumptions of peacetime engineering. The Normandy landings on June 6, 1944, were the largest amphibious operation in human history. 156,000 Allied troops came ashore on 5 beaches along the French coast. The planning had consumed years. Every detail had been studied: beach gradients, tidal patterns, German fortification layouts, air support requirements, naval gunfire coordinates, supply logistics, medical, evacuation procedures, communications, protocols. The planners had considered thousands of variables. They had built specialized tanks for specific tasks: duplex drive Shermans that could swim ashore, flail tanks to clear mines, armored bulldozers to breach obstacles, Churchill AVREs to demolish fortifications. The British had even created an entire array of modified vehicles called Hobart's Funnies, each designed to solve a specific problem identified during planning. The beaches were taken. The Atlantic Wall was breached. By the end of D-Day, Allied forces held a toehold in France. The plan had worked. Now came the advance inland, into the countryside, into the bocage. Bocage is the Norman word for a specific type of terrain, mixed woodland and pasture, small fields enclosed by hedgerows. The hedgerows themselves were not simple rows of bushes. They were earthen embankments, built up over centuries. Farmers had cleared stones from their fields and piled them along property lines. Generation after generation, the piles grew higher. Dirt accumulated. Vegetation took root. By 1944, these hedgerows had become walls of earth and vegetation, 4 feet high at their base on average. Some reached 10 feet or more. Some extended to 15 feet, counting the mature trees growing from their tops. The root systems of these ancient hedges had intertwined over hundreds of years, creating dense mats of growth that held the earthen walls together. The hedgerows, enclosed irregular fields, typically no more than 300 feet across, sometimes much smaller. An aerial photograph from 1944 shows approximately 3,900 hedgerow-lined fields in an area of less than 8 square miles. From above, Normandy looked like a vast patchwork quilt. From ground level, it looked like a maze of earthen fortifications. The Allied planners had known this. The Cossack invasion plan, developed in 1943, specifically mentioned the bocage. General Frederick Morgan had alerted the British chiefs of staff to the difficulties the terrain would pose. Intelligence officers had studied maps. They had examined aerial reconnaissance photographs. They had consulted with French civilians who knew the region. They had noted that the bocage would complicate operations. What they had not done was understand what this terrain meant for armoured warfare. They had not grasped that centuries-old farming practices had created a landscape ideally suited for defence. They had not realised that each hedgerow-enclosed field was a natural killing zone. They had not calculated that the American sector, west of the Orne River, would be dominated by this terrain for miles inland. They had planned for the beaches. They had not adequately planned for what came after. The doctrine was clear. After the landings, armoured divisions would exploit the breakthrough. They would push inland rapidly. They would seize key terrain. They would cut German supply lines. They would prevent the enemy from establishing coherent defensive positions. Speed and mobility were essential. The plan assumed that once past the coastal fortifications, Allied armour would have the freedom to manoeuvre. The Sherman tank was supposed to make this possible. The M4 Sherman medium tank, in its various models, was the backbone of Allied armoured forces, 30 to 35 tons, depending on variant, powered by various engines producing between 350 and 500 horsepower, armed with a 75mm main gun, armoured with 51mm on the frontal hull, crewed by 5 men, reliable, maintainable, available in enormous quantities. American factories were producing thousands of Shermans. The Detroit tank arsenal alone could build nearly 100 tanks per month during peak production. The Sherman was not the best tank of the war, but it was good enough, and there were enough of them. That was the American approach to armoured warfare. Adequate equipment in overwhelming numbers, the Sherman could handle most terrain. It could ford streams. It could climb moderate slopes. It could push through light obstacles. Its ground pressure was reasonable for its weight. Its suspension was reliable. It had proven itself in North Africa, in Sicily, in Italy. The tank worked, until it met the bocage. The first American tanks pushed inland from the beaches in early June. They followed the roads at first. The roads were narrow, sunken lanes between high hedgerows. Centuries of use had worn the roads down below the level of the surrounding fields. Trees growing from the hedgerows on both sides often met overhead, creating tunnels of vegetation. The tank commanders could see perhaps 50 yards ahead, sometimes less. The Germans understood this terrain. Many of them had been in Normandy for months, preparing defences. They had studied the Bocage, they had recognized its potential. Each field was a compartment, each hedgerow was a wall, each sunken lane was a trap. Small groups of defenders with anti-tank weapons could control large areas. They did not need elaborate fortifications. The terrain itself was the fortification. When American armor tried to leave the roads and move cross-country, the problems became clear. A Sherman, approaching a hedgerow, had two options. It could try to find a gap, one of the few openings where farmers had placed gates. These gaps were obvious. The Germans covered them with machine guns, mortars, and anti-tank weapons. A tank moving through a gap was a target. Or the tank could try to go over the hedgerow itself. The Sherman would approach the earthen wall. The driver would give it throttle. The tank would climb. The front would rise. Higher, higher. The belly would be exposed. The bottom armor on a Sherman was between 19 and 25 millimeters thick, depending on the variant. Thinner than the frontal armor. Vulnerable. And as the tank crested the hedgerow, its gun would point skyward. The tank could not fire effectively in this position. It was helpless. German soldiers with panzerfausts, handheld anti-tank weapons, waited for this moment. One shot into the exposed belly. The shaped charge would penetrate the thin armor. The explosion would kill the crew or detonate the ammunition. Even if the tank survived, it was disabled, stuck on top of the hedgerow, blocking the advance, creating an obstacle for the tanks behind it. American tank crews learned quickly that going over hedgerows was suicide. But going through the gaps was nearly as bad. The Germans had positioned their weapons to cover every obvious route. The Americans tried using explosives. Combat engineers would place charges at the base of a hedgerow and blow a hole through it. This worked, sometimes. But it was slow. It required engineers to work under fire. It required large quantities of explosives. And the explosions advertised exactly where the Americans were trying to advance. German artillery and mortar crews would already have the coordinates registered. The moment they heard an explosion, they would fire. Men died setting charges. Men died waiting for charges to blow. The Americans tried using Dozer tanks, Shermans equipped with bulldozer blades. These could push through some hedgerows, given enough time and effort. But Dozer tanks were conspicuous. The Germans targeted them immediately. Each battalion had approximately 70 tanks. Only 4 of them were Dozers. Losing a Dozer tank meant losing a critical capability. The Dozer tanks became priority targets for German anti-tank teams. The advance slowed, stopped. American units measured their progress in yards per day, sometimes in yards per week. Casualties mounted. The fighting in the Bocage was intimate and brutal. Small unit actions. Hedgerow to hedgerow, field to field. Companies attacked positions they could not see until they were already taking fire. Platoons were ambushed from 3 sides simultaneously. The compartmentalized terrain prevented coordination. Artillery support was difficult because the vegetation caused shells to detonate prematurely in the trees. Air support could not distinguish friendly from enemy positions in the dense foliage. The plan had called for rapid exploitation. The reality was grinding attrition. By early July, 6 weeks after D-Day, the American army had advanced approximately 15 miles inland. They were supposed to have broken out by now. They were supposed to be racing across France. Instead, they were trapped in the Bocage, fighting for every field, losing men and equipment to an enemy that used the terrain brilliantly. Something had to change. The question was what? Sergeant Curtis Culin III was 29 years old in July 1944. He came from Cranford, New Jersey. Before the war, he had worked various jobs, surviving the Depression like millions of other Americans. He had learned to improvise, to make do with what was available, to solve problems with limited resources. These were not skills taught in engineering schools. They were skills learned from necessity. Culin served with the 102nd Cavalry, Reconnaissance Squadron, part of the 2nd Armored Division. The unit was equipped with light tanks and armored cars. Their job was to scout ahead of the main force, to locate enemy positions, to find routes for the armor to follow. In the Bocage, this meant moving through terrain where visibility was measured in yards, and every field might contain an ambush. He understood the tank problem intimately, not from technical manuals or tactical doctrine, from experience, from watching Shermans belly up on hedgerows, while German anti-tank teams took their shots, from seeing good crews die because the terrain made their tanks vulnerable, from recognizing that the equipment they had was not suited for the battlefield they faced. The problem was being discussed throughout the American units in Normandy. Officers and enlisted men talked about it constantly. How do we get through these hedgerows without exposing ourselves? Various units tried different solutions. The 79th Infantry Division developed a hedge cutter by early July. It used modified Dozer blades. It worked somewhat. The 19th Corps demonstrated a set of prongs initially designed for placing explosives. The prongs could lift portions of the hedgerow. 5th Corps units invented devices they called brush cutters and green dozers. None of these solutions were perfect. None were adopted army-wide. The discussions happened at every level. In command posts, in maintenance areas, in the fields between attacks, men who were doing the fighting talked about the problem they faced. They proposed ideas. Most ideas were impractical. Some were impossible. A few had potential. In one of these discussions, sometime in early July, a group of men from Culin's unit were talking about the hedgerow problem. Someone, a soldier the men later described as a Tennessee hillbilly named Roberts, made a suggestion. Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges? The other men laughed. It sounded absurd. Saw teeth on a tank, like something from a cartoon. The idea seemed too simple, too crude. Tanks were sophisticated machines. Engineering solutions required engineering expertise. You could not just weld some metal to the front of a tank and expect it to solve a problem that had stumped the entire army. Culin did not laugh. He was looking at Roberts, thinking about what the man had said. Saw teeth, cut through, not over, through. The concept had potential. The hedgerows were earth and vegetation and roots. They were tough, but they were not steel. A tank had tremendous force. What if that force could be directed through the hedgerow instead of over it? What if you could prevent the tank from climbing by giving it something to bite into the base of the wall? He started sketching, working out the concept. The device would need to be strong enough to penetrate the earthen embankment. It would need to be angled to drive into the base of the edifice, hedgerow. It would need to pin the tank's belly down while it pushed through. 4 prongs, maybe. Or 3. Welded to the front hull. Made from something strong. Steel beams. The beaches were covered with German obstacles. Czech hedgehogs. Massive steel structures made from railway rails or I-beams, welded together in X shapes. The Germans had scattered thousands of them across the landing beaches to stop tanks and landing craft. The Allies had pushed through them on D-Day. Now they lay abandoned. Tons of high-quality steel, free for the taking. Culin went to work. He gathered scrap, metal from the beach obstacles. He found welders. He drew plans. He supervised the construction of a prototype. The device looked crude because it was crude. 4 steel prongs protruding from the front of a light tank, angled downward, sharpened at the ends. The whole assembly welded directly to the tank's hull. The men tested it. The tank approached a hedgerow. The driver gave it throttle. The prongs bit into the earthen wall. The tank's belly stayed level. The tank pushed through. The hedgerow exploded in a shower of dirt and vegetation. The tank emerged on the other side, level, intact, ready to fight. It worked. The hedgerow problem should not have surprised anyone. The information was available. French maps clearly showed the Bocage. Aerial reconnaissance had photographed the terrain. Intelligence reports had described the hedgerows in detail. Officers who had studied the region knew about the enclosed fields and earthen walls. But knowing about terrain is not the same as understanding how that terrain affects combat operations. The men who planned the invasion did so from offices in England. They studied maps and photographs. They consulted experts. They developed sophisticated plans. What they did not do was imagine what it would be like to fight in that terrain, at ground level, in a tank, under fire, with limited visibility, and German anti-tank teams waiting in positions they had prepared for months. This was not incompetence. The Allied planning for D-Day was extraordinarily thorough. The logistical preparation was unprecedented. The coordination between air, naval, and ground forces was masterful. The specialized equipment developed for the landings demonstrated remarkable foresight. The planners had thought of nearly everything. They had not fully grasped that the Bocage would neutralize Allied advantages in armor and mobility. They had not calculated that terrain, which had evolved over 8 centuries of farming, would create a defensive system superior to anything human engineers could design. They had not understood that small German units could use the hedgerows to hold off much larger American forces indefinitely. The failure was not in the intelligence. The failure was in translation. The information about the Bocage existed in reports and briefings. It did not exist in the minds of the men who would have to fight there. Tank crews training in England and the United States did not practice breaching hedgerows because no one had created training facilities that replicated Norman terrain. Infantry units did not rehearse field-to-field fighting because no one had built training areas with earthen walls, 12 feet high and 300 feet apart. The doctrine assumed that once past the coastal defences, armour would have room to manoeuvre. This assumption was based on experience in North Africa, where tank battles occurred across open desert. It was based on Sicily and Italy, where the terrain was difficult but did not compartmentalize the battlefield the way the Bocage did. The doctrine was not wrong. It was incomplete. When the American army encountered the Bocage in early June, there was no immediate solution available. The equipment they had was not designed for this terrain. The tactics they knew did not work. The training they had received did not apply. They had to learn by doing. They had to adapt under fire. Various units tried various approaches. Some commanders emphasized infantry armor coordination, using dismounted troops to clear hedgerows before tanks advanced. This worked but was slow and costly in casualties. Some units relied on artillery to blast holes in hedgerows. This consumed enormous quantities of ammunition and advertised their intentions to the Germans. Some commanders used concentrated tank charges, accepting losses in exchange for momentum. This worked sometimes but depleted their armor strength. By early July, General Omar Bradley was deeply concerned. The First Army had been fighting in the Bocage for a month. Progress was measured in yards. Casualties were mounting. The Germans were reinforcing their positions. The weather was preventing full use of Allied air superiority. If the Americans could not break out of the Bocage soon, the entire Normandy campaign might stall. Bradley was planning Operation Cobra, a massive offensive designed to break through German lines and allow exploitation into open country. The attack was scheduled for late July. For Cobra to succeed, American armor had to be able to move through the Bocage efficiently. They needed a solution to the hedgerow problem. They needed it quickly. The solution was not going to come from the engineering establishment. It was not going to come from the Ordnance Department. It was not going to come from higher headquarters sending down a technical bulletin. The solution was going to come from a sergeant in the field who had listened to a hillbilly from Tennessee and recognized a good idea when he heard one. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. On July 14, 1944, Major General Leonard Gero telephoned General Bradley early in the morning. Gero commanded 5th Corps. He asked if Bradley could meet him at the 2nd Armored Division. He said there was something Bradley needed to see. He did not provide details over the telephone. Bradley agreed. He drove to the 2nd Division's area. He found Gero with several staff officers clustered around a light tank. The tank looked odd. A crossbar had been welded to its front hull. 4 prongs protruded from the crossbar. They looked like tusks. The whole assembly appeared crude, improvised, almost comical. Gero introduced Bradley to Sergeant Culin. The young sergeant explained his device. The prongs were made from German beach obstacles. They were designed to penetrate the base of a hedgerow. They would prevent the tank from climbing over the wall. They would allow the tank to push through instead. The design was simple, the fabrication was straightforward. Any maintenance unit with welding equipment could build them. Bradley listened. He had heard about various hedgerow cutting devices. None had impressed him particularly. This one looked too simple to work. But Gero seemed confident. Bradley agreed to watch a demonstration. The tank backed away from a nearby hedgerow. The commander gave a signal. The engine roared. The tank accelerated. 10 miles per hour. Directly at the hedgerow. The prongs struck the earthen wall. They bit in. The tank kept moving. The belly stayed level. The entire hedgerow seemed to explode. Dirt and vegetation flew into the air. The tank burst through, emerging on the other side under a canopy of debris. It had punched a hole clean through the wall. The tank remained level throughout. Its gun had stayed pointed forward. It could have engaged targets immediately. A Sherman tank moved into position. Same demonstration. The Sherman was heavier, more powerful than the light tank. It hit the hedgerow with the same result. The steel tusks bored into the wall. The tank's belly was pinned down by the prongs. The Sherman crashed through. Not over. Through. The hedgerow that would have been an obstacle became a cloud of dirt. Bradley watched in silence. He was seeing the solution to a problem that had cost his army thousands of casualties and 6 weeks of grinding combat. The solution was absurdly simple. So simple that it had baffled an entire army for more than 5 weeks. So simple that a sergeant had built it in a field workshop from scrap metal. So simple that it required no sophisticated engineering, no complex manufacturing, no specialized parts. Bradley later wrote about this moment in his memoir, A Soldier's Story. He described watching the demonstration. He described his realization that this crude device would revolutionize warfare in the Normandy section of France. He described ordering the device to be manufactured in quantity immediately. The orders went out that day. Lieutenant Colonel John Medaris of the Army Ordnance Department was dispatched back to the United Kingdom. His job was to arrange for tanks to be fitted with the device before being shipped to France. Bradley arranged for additional arc welding equipment and welding crews to be flown to Normandy. Every ordnance unit in the First Army received orders for round-the-clock production of hedgerow cutters. The scrap metal came from the beaches. Thousands of German obstacles still littered the sand. Cutting torches and welding equipment turned Czech hedgehogs into tank tusks. Each cutter was handmade. Each one was slightly different depending on the welder's skill and the specific materials available. Quality varied, but they all worked. Between July 14th and July 25th, 500 cutters were manufactured and installed. 3 out of every 5 tanks in some units were equipped with them. The tanks equipped with the device were nicknamed Rhinos by the soldiers. The name stuck. The Culin Rhino, the hedgerow cutter that would change the campaign in France. Operation Cobra launched on July 25th. The Rhino tanks tore through hedgerows the Germans had expected to be impassable. The breakthrough succeeded. Patton's Third Army poured through the gap. The race across France began. Sergeant Curtis Culin received the Legion of Merit for his invention. The award recognized exceptional service to the United States. It was presented with ceremony and publicity. Newspapers back home ran stories about the sergeant from Cranford, New Jersey, who had solved a problem that stumped an army. Culin became, briefly, a national hero, the kind of hero America liked during the war. An ordinary man who had done something extraordinary through ingenuity and determination. Culin tried to give credit to Roberts, the Tennessee soldier whose offhand comment had sparked the idea. Culin mentioned Roberts in interviews. He told the story honestly. He acknowledged that the original concept had not been his alone, but Roberts disappeared into the anonymity of the enlisted ranks. History forgot his name. The device became the Culin hedgerow cutter. Culin became the inventor. Roberts became a footnote, mentioned by some historians, forgotten by most. 4 months after his invention changed the campaign in France, Culin stepped on a landmine in the Hurtgen forest. The mine detonated. Culin lost a leg. He was evacuated from the combat zone. He would not return to the fighting. The war was over for him. He had contributed something significant to the Allied victory. The cost was permanent disability. After the war, Culin returned to the United States. He married Bernice Enright in 1945. They settled in New York City. Culin took a job as a salesman for Schenley Industries, a liquor distributor. It was ordinary work, nothing glamorous, nothing that drew on his brief fame. He was a veteran among millions of veterans, a man who had served and come home and tried to build a normal life. President Dwight Eisenhower mentioned Culin in speeches years later. In January 1961, Eisenhower addressed the American Society of Mechanical Engineers. He told the story of the hedgerow cutter. He emphasized how a sergeant's idea had been taken seriously by the chain of command, how captain had listened to sergeant, how major had listened to captain, how General Bradley had acted immediately when he saw the device work. Eisenhower used the story to illustrate the importance of listening to ideas from any source, regardless of rank or formal expertise. In 1964, Eisenhower repeated the story in a television interview with Walter Cronkite. The interview was filmed in Normandy on the 20th anniversary of D-Day. Eisenhower and Cronkite stood in the actual hedgerow country. Eisenhower described Culin's invention. He talked about how it had restored morale throughout the army, how soldiers who had felt trapped and helpless suddenly had a tool that worked, how the psychological impact of the Rhino tanks was as important as their tactical effectiveness. Curtis Culin died in Greenwich Village, Manhattan, in November 1963. He was 48 years old. He is buried in Westfield, New Jersey. There is a plaque dedicated to him on a boulder on the Fear, North Union Avenue side of the Cranford Municipal Building. Most people walk past it without noticing. The hedgerow cutter itself became a subject of historical debate. Some historians, including armor specialist Stephen Zaloga, have argued that the device was not as widely used or as effective as popular legend suggests. They point out that many tanks broke through the Bocage without Rhino devices. They note that improved infantry armor tactics and overwhelming American firepower were more important to the breakout than any single technological innovation. Other historians, including Max, Hastings and Chester Wilmot, credit the invention with restoring battlefield maneuverability to the Allied forces. They argue that the psychological boost was real and significant, that soldiers who had felt helpless against the terrain suddenly had confidence they could overcome it, that this confidence translated into aggressive action that broke German defensive positions. The truth is probably somewhere between these positions. The Rhino was not a miracle weapon, but it was a useful tool that came at a critical moment. It solved a real problem. It gave tank crews options they had not had before. It contributed to the success of Operation Cobra. Whether it was decisive or merely helpful is perhaps less important than what its existence revealed about the American military in 1944. The hedgerow cutter was a small thing in a vast war, a welded assembly of scrap, metal, a field modification, one innovation among thousands developed during World War II. But it illuminated something significant about how the United States fought that war and why the United States won. The American military in World War II was not the most experienced. German officers had been studying warfare for decades. German tactical doctrine was sophisticated. German soldiers were often better trained individually than their American counterparts. The Wehrmacht had fought across Poland, France, the Soviet Union, North Africa. They knew their craft. The American military was 2K, not equipped with the best individual weapons systems. German tanks were superior to American tanks in armor, protection, and firepower. The Panther and Tiger outclassed the Sherman in direct combat. German machine guns fired faster than American machine guns. German anti-tank weapons were more powerful than American equivalents. What the American military had was adaptability backed by overwhelming industrial capacity. When American forces encountered a problem, they could develop solutions quickly. When those solutions required equipment, American industry could produce that equipment in quantities that would have seemed impossible to any other nation. The hedgerow cutter exemplified this approach. The problem was identified in early June. By mid-July, a solution had been developed in the field. By late July, 500 tanks had been modified. Within weeks, thousands more were equipped with various hedgerow cutting devices. The British developed their own version, called prongs. 600 Mark I prongs were delivered by August. 1,000 Mark II prongs followed. 500 Mark III prongs for Cromwell tanks. The entire Allied armoured force in Normandy was being retrofitted with equipment that had not existed 2 months earlier. This was not planned. This was not part of the original invasion concept. This was reaction to battlefield conditions. But the reaction was fast, effective, and supported by an industrial base that could turn scrap metal into tank modifications at scale and speed. The fact that the solution came from a sergeant rather than from the engineering establishment was significant. It demonstrated that the American military, for all its faults, had created a culture where ideas could move up the chain of command, where a sergeant could propose something, and a captain would listen, and a major would test it, and a general would see it demonstrated, and orders would be issued that same day. This was not universal. Many ideas from enlisted men were ignored. Many good suggestions died in the bureaucracy. The American military was hierarchical and often rigid, but it was not so rigid that a good idea from a low-ranking soldier could not reach decision-makers. Bradley saw the demonstration on July 14th. Production orders went out that day. That speed of decision-making was remarkable. The Germans, for all their tactical sophistication, struggled with this kind of adaptation. German industry was already strained by 1944. German supply lines were being strangled by Allied air power and naval blockade. German decision-making was centralized and slow. When German forces encountered problems, solutions took months to develop and implement. Often the solutions never came at all, because the resources were not available. The hedgerow cutter also revealed something about American attitudes toward technology and problem-solving. Americans were comfortable with improvisation, with making do, with crude solutions that worked, rather than elegant solutions that did not. The Rhino device was ugly. It was unsophisticated. It added weight to the tank. It probably affected handling characteristics. Engineers looking at it from a purely technical perspective might have found a dozen things wrong with it, but it worked. That was enough. American pragmatism valued results over elegance. If welding scrap metal to a tank solved the problem, then that was the solution. Refinements could come later. Victory did not require perfection. It required solutions that worked well enough to accomplish the mission. This mindset, combined with industrial capacity, created a military force that could adapt faster than its enemies could counter-adapt. The Germans would eventually develop tactics to deal with Rhino tanks, but by then, the Americans had broken through. Patton was racing across France. The Bocage was behind them. The hedgerow cutter solved a problem that should never have existed. That is the uncomfortable truth at the center of this story. The Allied invasion planners knew about the Bocage. They had maps, they had intelligence, they had French civilians who could have described the terrain in detail. They chose not to fully account for it in their planning. This was not malicious, it was human. Planners cannot anticipate everything. Some things only become clear when troops encounter them in combat. But the hedgerow problem was foreseeable. The information existed. Someone should have recognized that earthen walls, 12 feet high, enclosing fields 300 feet across, would create tactical problems for armor. Someone should have created training facilities in England that replicated Bocage terrain. Someone should have tested tanks against hedgerows before D-Day. Someone should have developed cutting devices during the planning phase, rather than leaving it to field improvisation under fire. These things did not happen. The cost of that failure was measured in lives. American casualties in the Bocage during June and early July 1944 were severe. Exact figures vary depending on sources, but the First Army suffered tens of thousands of casualties fighting through terrain that neutralized their advantages. Some of those casualties were inevitable. War kills soldiers, but some casualties occurred because tanks could not breach hedgerows effectively, because infantry had to assault positions without adequate armor support, because the equipment and tactics were not suited to the terrain. How many men died because the hedgerow problem was not solved until July? How many were wounded? How many tanks were destroyed? The numbers are unknowable. Causality in combat is too complex to isolate individual factors, but the human cost of inadequate preparation was real. The soldiers who fought in the Bocage before the Rhino tanks arrived learned through experience what planners should have taught them, through training. They learned that going over hedgerows exposed their tanks. They learned that existing gaps were death traps. They learned that explosives worked, but drew artillery fire. They learned these lessons by watching their friends die. Curtis Culin's invention saved lives after July 14th. It made the breakout possible. It contributed to shortening the war in France. These are significant achievements, but they do not erase the fact that the problem existed because of inadequate planning. The triumph of field innovation was necessary because institutional preparation had failed. This pattern repeated throughout the war. American forces encountered problems that could have been anticipated. They solved those problems through ingenuity and industrial capacity. They won battles and campaigns through adaptation. But adaptation is expensive. Solving problems under fire costs more than solving them before the shooting starts. The hedgerow cutter is remembered as a success story, an American success story, the kind that emphasizes individual initiative and practical problem solving. These elements were real. Culin did solve a problem. The army did respond quickly. American industry did produce the equipment needed. These are things to recognize and respect. But success stories are more valuable when they include honest assessment of failure. The Allied invasion planning failed to adequately prepare for Bocage fighting. That failure cost lives. It delayed the breakout. It gave German forces weeks to reinforce their positions. These costs should be acknowledged alongside the success. On the morning of July 14, 1944, General Bradley watched a Sherman tank with crude steel tusks welded to its front punch through a Norman hedgerow. He recognized immediately that this device would change the campaign. He was right. But he was also witnessing evidence of a planning failure, a failure that his army had overcome through the efforts of men like Culin, men who saw a problem, thought of a solution, and made it work with the materials they had. That is how wars are won. Not through perfect planning, not through superior equipment, but through imperfect people solving unforeseen problems with whatever they have available. That was true in 1944. It remains true today. Thank you for watching. For more detailed, historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.